This video shows a typical scenario using infrared inspection of an overhead transmission line to identify a hot splice, and then the proper correction of that hot splice using a Clamstar engineered mechanical shunt.
Right base 1833.
Step 1 will be to locate the hot splice. As you can see in this clip, a hot splice has been identified.
That is very hot.
This is a 230 kV 1590 ACSR conductor. The aerial line crew will now go through the process of installing a Clamstar unit, which, for this application, is a CSR 1631048 unit. After bonding onto the live line, the lineman will brush the conductor on both sides of the splice to remove oxidation and roughen up the surface to improve conductivity. And since all Clamstar units are pre-filled with high temperature inhibitor, designed especially for use on aged, weathered conductor, clean, dry brushing is all that's necessary. To save time, we're speeding up the video here. The next step will be to set the body of the Clamstar on the conductor properly centered over the splice. He'll use a short rope to temporarily secure the Clamstar body to the conductor. The lineman will then slide the attachment heads on one side at a time. This is achieved by lining up the edges of the head with the receiver grooves on the body. Once lined up correctly, the head will slide in until it hits the stop point. Once the head is in place, the lineman begins tightening fasteners using the power driver. He'll take one pass on all 20 bolts to snug them up before he comes through for a second pass to tighten them some more before he passes one final time to snap the torque heads off. This torque shear feature reduces overall installation time and eliminates the need for a torque wrench. The pilot and lineman are both doing an outstanding job despite very high wind conditions. The process is repeated on the other side of the splice. The safety rope is detached, and now that splice has been permanently corrected. To validate the amazing resistance lowering characteristics of Clamstar, the line crew returned a week later to check the resistance on the line. They took 3 readings. One reading on the left side of the splice showed 8 microohms, one reading on the right side of the splice showed 7 microohms, and one reading of the conductor by itself showed 12 microohms. This graph illustrates 3 actual splice temperature readings: the operating temperature of a new splice, splice temperature in failure mode, and the splice and the Clamstar temperature after Clamstar has been installed, which now reads only 27 degrees Fahrenheit. Clamstar eliminates risk and prevents catastrophic connector failures before they happen, without costly replacement, repair, or expensive downtime in just minutes. Clamstar is the industry's only permanent solution for protecting overhead splices and connectors.